Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar, brought to you by TechStrong and Fairwinds. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting webinar ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in using the Q&A tab, which can be found on the right side of your screen. This is also where you will find the chat tab. That's where we want you to engage with each other, engage with us. Let us know your thoughts throughout today's program. We do have 2 polls that we will be launching throughout today's webinar, so be sure to keep an eye out for those as we do want your participation. And if you direct your attention to the handouts tab, you will also find a copy of today's slides available for download. So feel free to download those at your own leisure. And finally, before we close, of course, we'll be giving away 4 $25 Amazon gift cards. So be sure to stick around until the very end. So our topic today is Kubernetes, the good, the bad, and the misconfigured. And joining me is Rachel Sweeney, Insights Enablement Engineer at Fairwinds, and John Hashem, Senior Solutions Architect at Fairwinds. John and Rachel, thank you both so much for joining me today. I'm going to let you run with it from here.
Awesome. Thank you so much, Cody. I feel like you need one of those news broadcaster intros where it's like dun 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 dun, and then you're like, good morning, good evening, and yeah.
Coming soon.
Anyway, so we're here for Kubernetes, the good, the bad, and the misconfigured. My name is Rachel Sweeney. I've been a number of different roles here at Fairwinds. I was a site reliability engineer for a while, working on maybe around 100 clusters, managing those and helping out. Moved over more towards helping out with technical enablement for some of our software. And so, excited for this talk. John, you want to introduce yourself?
Sure. Hi, everyone. John Hashem, one of the solution architects. Just going to walk you through a little bit of the presentation with Rachel. Been helping out on the technical enablement front with Rachel as well. So, it's been a lot of fun here at Fairwinds.
All right. So what have we got? So the Fairwinds mission is to be the trusted partner for Kubernetes security, policy, and governance. With Fairwinds, customers ship cloud-native applications faster, more cost-effectively, and with less risk. We provide a unified view between dev, sec, and ops, removing friction between those teams with software that simplifies complexity. So what that means essentially is, at Fairwinds, we have a lot of open source tooling that helps to solve a lot of problems that we've seen come up from managing clusters, doing professional services and stuff like that. And then we also have our own software as a service, piece of software that we use to help solve a lot of those problems. And so, we've got plenty of experience here in the Kubernetes space from working with tons and tons of clients. We see a lot of problems come up over and over again. And so we're going to jump into those. Real quick, one thing I forgot to mention is if you have any questions during this presentation, please feel free to throw them in the chat at any point. We might not be able to get to them the second you ask, but it will be certainly helpful to collect them by the end of the presentation. That way we can go through them, answer anything that comes up, and go from there. So let's start off with a quick poll. Where is everyone here in their Kubernetes journey? A, are you learning about containers in Kubernetes? B, maybe you're planning to use them in 6 to 12 months. C, are you using only in testing and in a development environment? Or D, are you using it in production? This is another one of those moments where like elevator music would be good. Maybe Jeopardy.
Yeah, Jeopardy sounds good.
There weren't those copyright pieces.
All right.
Leesburg, Virginia. I'm in the Washington, D.C. area, so not too far from there. I see someone else is from Mexico. Hello. Glad to see people joining us from all over. All right, so it looks like more people are using it in production at the moment. And then we've got a pretty decent spread across people learning about it, planning to use it soon, just getting into testing it. Is elevator music ever good? Yeah, very subjective thing. Good question. All right, so moving on, it's helpful knowing that most people are starting to using it in prod. So one thing we found is that only 35% of organizations have correctly configured most of their workloads with liveness and readiness probes. This is something that we see, often in a lot of people that we work with as well. And it's a pretty critical thing when it comes to stuff like reliability. If you want zero downtime deployments, for example, you're going to want to make sure that you have readiness probes enabled so that as you, deploy something new and the new thing comes up, the readiness probes give the load balancer, the Nginx controller, whatever it is, the okay that you can start diverting traffic to me. And so without those, you'll get some, dropped traffic. You'll start to run into issues. Liveness probes are another one. We see that happen a lot where a pod in Kubernetes running containers will end up crashing and having issues. And without liveness probes to restart it, sometimes it can kind of just get stuck there and run into issues. And we've seen that actually happen and cause some production outages. And it's a really great thing to have. How do you see that, John? Do you see a similar thing with the people you work with?
Yeah, absolutely. It seems like one thing that people tend to care about, but tends to get missed a lot of times. So I think this is fairly on par with what I see out there.
And so if reliability is something you care about, this is one of those configurations that often people just don't know that they need to be putting in if they're new to Kubernetes. By default, it won't necessarily have one there. And so it's up to us as the engineers to put that in, or whoever is responsible. And so that's a good configuration that we really want to get in place if reliability is something that we care about. So what else? Only 42% of organizations today manage to lock down most of their workloads. Security being a big thing here, as we move from, predominantly being in the cloud and still in the cloud often with Kubernetes to suddenly having all of those security levers moved into the Kubernetes area. There's now a lot of new ways that we can tighten down security and restrict workloads. And, by default, as soon as we spin up a Kubernetes cluster and get things up and running, there are a lot of things that are not configured for us. So there are insecure configurations that do lead to security issues that we need to be aware of. And by default, Kubernetes can't make those decisions for us. That's something that we need to know about and put into place. There is some great open source tooling, like Polaris is a great one that shows configuration best practices. It's great for, figuring out these security things and why we should care about them. I highly recommend Polaris. It certainly taught me a lot about these things. John, anything you want to add to that one?
Yeah, not too much sad here. I think I would echo kind of the same, message I have here is it seems, a lot of organizations are trying to solve this problem, and it's definitely a difficult one to solve, but happy to chat about a little more here.
Yeah, and we definitely see that with some clients where, as soon as they start to realize what the security issues are in their cluster, they're like, oh, I had no idea that was not locked down. And, it's kind of those unknowns that it helps to be aware of or figure out where to look to get that information. So we found that 54% are leaving over half of their workloads open to privilege escalation and thus security holes. So this is pretty similar. You might say that I want these permissions for my container to run in Kubernetes. If you don't lock down privilege escalation, that container or that pod could try and escalate its privilege. And that's one thing that the Kubernetes API can restrict. And so if you, say allow privilege escalation to false, then the Kubernetes API will not allow those pods to be able to escalate privileges. And that's usually a pretty simple one to do. It's just adding one piece of information in your YAML manifest that locks down privilege escalation. And I know we'll go on a bit more into security in a minute. So before we move on, anything there you want to add, John?
Yeah, this is definitely one of my favorite ones. I actually got from a customer recently. They were mentioning that a lot of their developers, they know this is not a best practice that they want to institute in their environment, but a lot of them don't even know how to fix it. Where does it live? So a lot of times they just don't configure it. So that's kind of a missing artifact in their environment. So definitely a common one here, pretty recently.
Yeah, that's a great point. And I feel like this is some of the lower hanging fruit here, just setting it to allow privilege escalation to false. with some of the harder ones might be, not running as root. Maybe a developer set up their container so that it requires root. And then if you just set in Kubernetes that we don't want to allow things to root, that could break a container if it's set up to need root. And really, the container should be architected so that it has the permissions it needs and nothing more. The principle of least privilege. So moving on from here, we're going to jump into some infrastructure as code scanning and how that helps. John, do you want to lead this one?
Yeah, I actually see a quick question here coming up. I want to tackle quickly. So it's what kind of issues do you see often with customers? From my experience, most of the ones that I see are, come down to things like, readiness or liveness probes not being set, image pull policy not setting as always, so you're not pulling, cached images, such as like if not present. And then memory and CPU requests not being set seem to be the top 5 that we see a lot. Or Rachel, if you can, if you see something similar, or just curious on your experience as well.
Yeah, that's a good point. Those are definitely the common ones that come up over and over and over again. Those are the pretty granular things. As far as like bigger buckets, I think security and cost are some of the things people care about a lot. And so there's a lot there with like image scanning from, supply side attacks, bringing in all these images into our clusters. And so do you know what vulnerabilities are in there? Stuff like that. And then, we provisioned all these nodes and we've set up Kubernetes to scale out horizontally. And so as it does, our cost grows and we don't know how efficiently we're using that cluster. So that's an issue that people often have as well. But yeah, for those action items, those were great ones.
Awesome. Great question. Thank you. All right. So jumping off here into everyone's favorite infrastructure as code, definitely a popular topic in the community. And one thing that we find is, when you start to look at all of your code that's out there, in your repositories, whether you're deploying it manually or using, some type of, GitOps workflow, there's a lot of either misconfigurations or security issues that could be present in either your Helm charts or Kubernetes manifests, and that becomes tricky to manage at scale, especially where we're seeing kind of a one-to-many relationship for kind of operators, SRE platform engineering folks to developers. So there's a lot of ways to kind of do some policy enforcement can really help with these type of issues.
Yeah, that's a great point. And also how, as we catch these things, while we're scanning repos and stuff, we can get it before it even gets into, staging or production or wherever it is. And so it's a lot cheaper from a business standpoint to solve these issues before they get into the cluster. And then it's much more expensive to remediate after the fact.
Great point. All right, so there's some opportunities here. So, reducing human error. If you have something that's scanning on your behalf, putting a consistent rule structure in place, you can kind of reduce the human oversight. It's also expensive to perform and really time consuming. You also have things like pod security. So there's a lot of things that are changing with Kubernetes as it's always evolving. Things get added, things get deprecated, like pod security policies. So this is a way for you to not only change, but kind of innovate on some of that behavior. RBAC is another one that becomes really tricky to manage. There's a lot of ways to authenticate within Kubernetes. And more importantly, if you want to scan against those best practices, there's no better way to start early. And lastly is just making sure that developers can really accelerate on deploying onto Kubernetes and not really have a hindrance on we got to check one more thing or we need to do this to make sure innovation is occurring in your enterprise today. So this is something where having a tool that can quickly identify those issues before either they become in the cluster or start really becoming true problems in your environment is something that you're definitely going to want to tackle.
And to add to that, another thing that we talked on a little bit earlier is catching vulnerabilities that get into the cluster, or catching them before they get in the cluster, rather. If you have things like Trivy, another great open source tool that is scanning for vulnerabilities in container images, we can see whether or not there's vulnerabilities in there before we even deploy it into our infrastructure. So if a developer is just doing some work locally on their machine, they've got a great image that they want to use, and they are starting to build out that Docker file, they push it up to your repo of choice, GitHub, whatever it might be. And then Trivy says, this is actually a pretty, there's some pretty huge vulnerabilities in this. It's a great chance to catch those things early there as well.
All right. So this is kind of one of the interesting parts of, within Kubernetes. We see a lot of cloud, Kubernetes out there, but obviously, on-premise as well. And really what's something to keep in mind is a lot of inefficiencies. Kubernetes is always scaling on either a metric or adding nodes to support new workloads. And in turn, that costs money. Or, if you're not, if you're oversizing workloads, that's really going to be a cost that you're going to have to, see in your cloud bill, or you're going to have to add new hardware to support those new workloads. So having a way to right-size those workloads to spec, to making sure that using the most out of your environment today is something kind of top of mind for a lot of organizations, because quickly they start to see once their cloud bill is too high, recouping that money that they've already spent is kind of long gone. It's something that you have to think and need rules for the future.
Yeah, it's definitely, I see the same thing as well. And it is amazing how, as we go to Kubernetes, we just don't tweak all those knobs to make things more efficient, and it can get away from us pretty quickly.
Next slide. All right. Yeah, so this is where the kind of opportunity starts here. So you want to build in all your, checks and everything from the beginning of your journey. It makes it a lot easier for users or developers in your organization to understand standards that you want to have achieved. So whether, looking at a few different example checks here, reliability checks, limits on resources to make sure you don't have noisy neighbor problems, or making sure you have a set amount of resources that this workload should consume. That's one area. Another one that's very popular as well is setting rules like anti-affinity to make sure different pods are running on different nodes, can help for fault tolerant situations as well, and planning out those best practices that make sense for your application or your organization. And lastly, to kind of echo a lot of Rachel's points on liveness and readiness probes, for zero downtime deployments, or just making sure, the obvious things like, rolling nodes or, performing upgrades, just a lot of kind of best practices that you want to have in place. And this is one that comes up quite often in items missed.
Yeah, another one, it is amazing to me just how many ways there are to tweak Kubernetes or things that affect reliability. And another one that I don't think is on the slide is talking about like quality of service. When we set memory and CPU requests and limits, we're telling Kubernetes, we want to request this much compute or memory. And if we set a limit higher, then we're saying we want it to be able to burst that much. And so if you don't set any CPU requests or limits, then that workload has the lowest priority, so that if a node starts to fill up and Kubernetes has to start killing things off to free up resources, that is the lowest priority, the first thing to go, and those workloads could be killed off. So if it's something critical that you're running, you're going to want to set resource requests and limits from a reliability standpoint. And if it's something burstable, that's kind of the middle tier, to where it won't be the first to be killed off, and it gives it room to burst if it needs more resources than it thinks it does or than you think it does. And then finally, the guaranteed, which is the most preserved class, I guess, of resources. So if you have the same requests and limits, it's going to be the last thing to be killed. And so if you have something that absolutely must be running and it cannot be killed under any circumstances, that's the type of thing that you're going to want there. And you'll have to do some other work to make it stateless, of course, since it's going to get killed off at some point for upgrades, but that will at least make it safest. All right, so we've got another polling question. What is your greatest opportunity to improve your Kubernetes environment? Is it getting help with the basics? Is it general best practices assessment, improving the security posture of your clusters? Maybe it's saving money, or perhaps improving the reliability of apps running in Kubernetes.
I'm actually really excited for this result too. I'm really curious on what people are looking for.
Yeah, it'll be fun to see what our audience is, if it matches what we see across everybody we talk to, or if we have a group that's just focused on one thing. Yeah, it should be good. What is your background, John? Are you scuba diving?
I don't know. I kind of went with this one today. I'm not too sure. Feels right for the time. The weather's not too bad here, so I'm going for an underwater theme.
Somewhere in the beautiful deep blue.
I'll take it.
All right, so awesome. It looks like about half of the audience is focused on improving the reliability of apps running in Kubernetes. So I imagine the liveness and readiness probes are things that you really want to hear. If you're not already doing them, quality of service is something that's going to be important. So you should definitely look into that. Yeah, a lot of good stuff like that. Making sure you have CPU and memory requests set. Looks like some people are focused on improving the security posture, and then everyone else is pretty split across the rest. Awesome. John, do you want to talk some about insights?
Yeah, absolutely. Thanks, Rachel. So we have an interesting platform here for you. It's called Fairwinds Insights. So a lot of the problems that we were chatting about today for security, efficiency, reliability, those are a lot of the areas that we see teams struggle with in regards to Kubernetes, since it is an ever-changing environment. And the more important part is teams are scaling. They're adding different users in the organization. They're wanting to innovate, adding new applications, or taking those monoliths and turning them into microservices. And in turn, that increases more workloads, more users deploying into Kubernetes. And these are the three problem areas that Fairwinds help with. So looking at security, making sure you have visibility across all those different areas that we chatted about, things like privilege escalation, running as root, insecure capabilities, a lot of the common things that tend to get missed. And we can look at that very early in your CI process, all the way through production. So depending where your problems lie, if it's early in what they call shift left that we hear all the time, early in the development lifecycle, we can tackle it there. Or maybe it's maybe you're doing a good job on the left, and maybe everything is in cluster now. There's an opportunity for you to tackle that at both ends. Next is cost optimization. Kubernetes is, I guess, the beast of scaling. Everything is scaling and adding and removing all different workloads or nodes, which in turn will increase your cost. And really making sure that there's a couple of ways you can run into things like service limits, or you could also see that on your bill as well. Especially where, anytime you're adding and removing nodes to the cluster. So the Insights platform gives you an opportunity to help you choose the correct size and then show you kind of a little bit of a reward for your behavior. So if you make a change, we can actually show you the cost impacts accordingly. So that's a really great way to show a little bit of fruit for your labor. And last is setting guardrails. A lot of teams tend to struggle with, they like a lot of these different tools, but they tend to operationalize them at scale, rolling out rules across a bunch of different clusters, or, what's failing, what is passing, where should I spend my time on, tweaking and tuning these different knobs here. So that's an opportunity for a platform like Fairwinds Insights to help you deploy those policies at scale and really introduce guardrails in your organization. Anything to add here, Rachel?
I don't think so. I think we can jump into a demo, and that will help solidify some of that. So what we're looking at right now is the UI for Insights. And Insights is the software as a service that we have at Fairwinds. And it's built on a lot of open source tools. And so we're going to talk about the open source tools in just a second, since I think a lot of you will find a lot of interest there. And when we first get into Insights, what we can see is we can see all of the clusters that we manage. So in this situation, there's maybe a dozen clusters or so that we all have reporting data into this platform, into the Insights UI. We can see what the health score is and how many action items are coming up from those. So the action items are made up of configuration best practices like reliability. There's a lot of security things. The alpha prod cluster, for example, has 458 things that are going against best practices or that could use some attention. And so at scale, you can see how this would quickly get out of control. And with this UI, it's easy to see one place to see how everything is doing. So if we go into a particular cluster, like US East Prod, for example, we can see here that it shows how these action items have changed over the course of time. We can see the score, whether they're critical, high, low, what the priority is on these different things. along with things like cost and some other good information. We can kind of drill in from there. We can see the top action items here, like image pull policy should be always, memory limit should be set, CPU limit should be set, requests as well. Good things for reliability there. And then if we drill in over here to the install hubs, like let's say we're going to set this up, how the platform works is it installs all of these different plugins or open source tools. And so each open source tool is going to run and it's going to generate data from what's within your cluster. And it's going to surface that information up to the platform. So almost everything here is open source. I highly encourage you to go take a look. We'll go over it briefly. Polaris is a really good one for configuration best practices. So if you want to know about security, reliability, efficiency, stuff like that, Polaris is going to show you, do I have liveness and readiness probes set on every single resource? Do I have CPU requests and limits set? It's going to show you that across any cluster where it's installed and just give you all that good information along with how you can fix it. Trivy, we mentioned, is doing those, it's scanning images from containers. So it's detecting things like supply side attacks or, other stuff like that. What vulnerabilities are in the container? How can we do something about that? Open policy agent, this is what John was speaking about with guardrails. The OPA or open policy agent is good for, you can set up rules. And when you set up a rule that might say something like, I don't want any container images coming into my cluster that come from Docker Hub, because there's a lot of vulnerabilities in Docker Hub. You could create a rule that says no images from Docker Hub are allowed in my cluster. And OPA, as soon as it sees that, it can say this is not allowed in the cluster because we have a rule that says it can't come from Docker Hub. And the open policy agent working with the admission controller will actually block it. So if something comes in with an image from Docker Hub, the OPA will detect that, the admission controller will block it, and then it will not be in the cluster. And we've just created guardrails right there. Kubebench is another great security tool. It helps for checking your cluster against CIS benchmarks. Nova and Pluto are great ones for upgrades. So thinking of reliability, if you are going from Kubernetes 1.21 to 1.22, there are a lot of deprecated APIs. And they're specifically being removed in 1.22. And so if you're using them and you upgrade and you haven't changed to use the newer versions of the APIs, you're going to have things that are going to start not working correctly. And so Pluto is great for showing what those deprecated APIs are and if they have been removed yet. This is a tool that I rely on heavily for figuring out if I could upgrade clusters. Nova does a similar thing, but for Helm charts. It's not looking for deprecated APIs specifically, but it is going to look to see if there are any Helm charts that need updates. RBAC Reporter is going to keep track of roles and bindings for everything in our clusters. So we can see that in one easy to see place. Kube Hunter, another great security tool. This is kind of like a penetration testing tool. So it's going to see, are there any known holes that I can do or get access to in this cluster to be able to compromise it? It'll show us what those are, tell us how to fix them and go from there. And then we've got Prometheus Collector, and it is going to gather time series data on all of our workloads to show how much CPU and memory each workload is using. And then with that, we can get accurate cost recommendations over time. So I believe it takes like a 2-week rolling window. It looks at everything that happens during that time and says, based on these spikes that you had and how much you've used, we recommend setting this limit on your resource and this request. And if you do that, you will save this much money compared to what you're using right now. And Goldilocks is another similar thing, another great open source tool. It is a point in time recommendation. So it'll look at the resources you're using right now and give you recommendations there as well. So almost everything here is open source. All of these plugins, I highly recommend you check them out. The challenge that we've found is that doing this at scale becomes really complicated really fast. You can set up 10, 15 plugins here on your own. You can manage all of them. You can do that across a dozen clusters, but you can see how complicated that's going to get and how much overhead there is. One of the beautiful things about this platform is it consolidates it in one place and brings all that information into one easy to see location. John normally does these demos, and so I know he's probably got other ways he wanted to say stuff. Is there anything you want to add that I didn't miss, John?
I don't think I can top that walkthrough, so that was well done. Yeah, I think to echo Rachel's points here, the ease of installation is something that we hear as well. A single Helm chart can pass in all the values that you want to add or not, and you can tune all those different environments there. So it makes it easier for deployment, and that's kind of one challenge that we hear quite often is you look at all these tools and you're like, great, I use some of these or some of them are new to me. How do I roll this thing out? So that's a great way to make it easier for customers, and even CI as well, as we give you a lot of great templates to use out of the box, and you can tune them based on your build steps or however you want to scan against your infrastructure as code.
Awesome. Yeah, good points. So moving on from there, what types of things affect reliability? So we were just looking at all of these plugins. We've got almost all of them installed. And right now, every single hour, they are running in a cluster, and they are sending all that information up to the platform. And so from here, this is all the information that it found. So there's a lot of ways to filter through this, but right off the bat, we can see, across all clusters, we're managing like a dozen clusters here. Across all of these clusters, there's about, not too far from 4,000 medium severity action items we should pay attention to. Maybe we just care about critical. And so then we can filter down, like show me the 324 critical ones. And that's going to filter down by that. And so what are they? In 220 cases, this image has a vulnerability. So trivia is running in all of these different containers. We can click on that and it's going to show us, here's all the trivia reports. It looks like in the London prod cluster, there's things that have issues, like Jenkins has a vulnerability. And we can see what it is. Here's the particular image. Here's the vulnerabilities it has. At least one is critical, and lots of good information there. And some other ways to cut this or look at this data. We can, let's say we're not too focused on security right now because we feel like we're in a good place, but we care about reliability. So we could filter by reliability, since I think about half of the audience is pretty focused on that. And this is going to show us, what are the top reliability issues. Label is missing is one that comes from OPA. So in this case, we've set up our own custom rule that says we require our all workloads to have a label on it. And if it doesn't have a label on it, I want you to create an action item so I can get some visibility into this. And we can see, which resources don't have labels. Beyond that, it looks like there are 330 action items where image pull policy should be set to always. We could look at those. It looks like there's plenty of readiness probes that aren't configured and liveness probes across these dozens of clusters, along with, only one replica is scheduled. And so there's a lot of good stuff here for reliability that we can look through. And yeah, it's a great way to quickly get a good snapshot of like, how is my cluster doing? Maybe we want to drill down to a particular cluster. That's another great way we can do it and see just within this cluster what's important. And yeah, we can see what those workloads are, what namespace they're in, and then we can start to do things with that where we can give them to the people that care about them. So being a DevOps engineer, before I became a site reliability engineer, I did a ton of automation like most of us do. And the way I view this platform is that these action items are triggers. So as an action item comes in, we can automate a lot of behavior from there. So let's say that a liveness probe should be configured and it comes up in the Stoic Hawking namespace. Let's say that's one team in particular at our organization. Anytime that happens, we could set up an automation rule, which we'll look at a bit more. We can set up an automation rule to immediately send a Slack notification to the channel where that team works. So anytime they deploy something into the cluster and the namespace that they work in, they're going to get notified in their Slack channel if it's something that they should be doing. And so there's a lot of flexibility there. We can also send triggers to PagerDuty that can be automated. If you use Jira, maybe you want to set up tickets. Anytime the label is missing on a resource, we could automate that to have a ticket created in Jira for the particular team that cares about it. And there's a lot of flexibility with what we can do there. I really like the setup. I think there's a lot of ways to just take work off of my plate, put it on developers' plate. We talk about service ownership a lot, and this is a great way to help deliver that service ownership by getting it to the people who care about it. Yeah, anything you want to add to action items here, John?
Not too much to add. I think the only I can probably mention here as well is, think of this action item view as kind of your first view into like, where should I spend my time? Because the top view there is a way to really drill into the problem areas and then federate out to the different teams, using that service ownership theme. I think that's a real important way to take these action items and make them actionable. So sending them to the users who really care about them and sending them to the system of record, whether it's Jira, Slack, or some other system, via webhook.
Yeah, those are good options as well. And you can also hide them. Like, let's say, we got this action item from Kubebench about, checking master node configuration to ensure that this directory ownership is set at etcd. Maybe these are set and we're not worried about it anymore. We could set it up to where it automatically hides any action item that comes in. So you can really filter it down to only the information you care about and then deliver it to the people that, need to know and fix it. So moving on from there, that's a high level view of all of the information all of those plugins are giving us and how to work with it. What about cost? So cost is another thing that, a good portion of people care about. And using the Prometheus data and some other built-in information that Insights has, we can see at a high level, how much each cluster is using. And so right here, we can see the Alpha Prod cluster. It's only got 4 CPU cores. It's probably a Minikube cluster or something small like that. And it's got a total capacity of 4. This could be, hundreds or thousands, depending on your particular cluster. But of this capacity, we can see that we're currently only using 1.18 CPUs. So we're only using just over 25% of what we're paying for. Maybe that's to be expected, depending on what our tolerance is for how much extra compute we need. And we can also see like how much are requested. So if we're using 1.18 CPUs, all those workloads are requesting 2.77 CPUs. Maybe we expect it to be that high, maybe we don't. And if we don't, this is an easy way to quickly see that, we could lower this, we could save some money here. And then it's also going to show the limits, the limits being at 10.88 CPUs, quite a bit more than what we have, but it provides room for bursting. It's not uncommon to have the limits higher than what we have available to us, since we assume that in a lot of cases, not all workloads are bursting up at the same time. Again, those preferences are going to depend on your organization and what types of workloads you're running. But we can get a quick snapshot across all of our clusters. How is this looking? And we can see like, my favorite cluster is offline, or there's not enough data for some reason. We can quickly see what we need to look at and focus on. Here we can see cost across all of the clusters. So different color lines are going to show us different clusters, how much they're costing per day. And then we can see the capacity, the utilization. It looks like a lot of these clusters are almost at 100% utilization on this particular day. Maybe we rolled out some new service and we were expecting that, in which case we could see that in this instance, maybe we should have had more CPUs on these nodes, or maybe scaled out more horizontally so that we could spread those workloads out. We can also see the same thing for memory. So we can see what was the memory utilization. It looks like it's less than CPU. So it looks like we are CPU constrained in a lot of these clusters. That might change what type of nodes we want to get. Maybe we're using memory heavy nodes and maybe we need more general nodes. There's a lot of information you can glean from this to make good decisions with data. Really, really like this chart. It's a good way to get visibility into all the different clusters that you manage. Yeah, how have you seen this being used, John? Is it very similar, or?
Yeah, very similar. I think a lot of organizations tend to use utilization as kind of a watermark to say like how well I'm doing in regards to consuming this cluster. So if they want to stick at a 60 to 70% utilization, they can really understand which ones are higher or lower than that kind of waterline. So it's kind of a good visual aid as well. But we've been seeing a lot of customers tend to struggle with the cost of a cluster. Things like for an AWS, the cost and usage report, it's large, there's a lot of line items, and really doesn't tackle those individual workloads. So it's an area that we find to be fairly common as far as a configuration ask.
That's a perfect segue. Thank you. So yeah, if this is the high level, how do my clusters look from the 10,000 foot view? How do we actually do something about that? So if we can see that we don't want this much spare capacity because we're only using a little over 25%, how do we actually fix that? And so that's where we can drill down into the weeds a little bit more. And if we look at the specific workloads, let's go with the alpha prod cluster, for example. We can start to see how do the individual workloads actually affect this. So if we look at something like Prometheus metrics, we could see, you know, how much CPU and memory it's using. It looks like right here, you know, it's really not using a lot, and it looks like the limit is significantly higher than what it actually needs. And so it's going to give us a lot of recommendations for how we can tweak this. And we can see over time, you know, here's how much resources it's actually used. And maybe we're requesting, if we're requesting up here towards 190 megabytes, but we're only really using, you know, 2-3 megabytes, we could probably drop those requests significantly. And from there, we'll start to save a lot more money. And, you know, once this is run for a couple days, it's going to start to give more accurate recommendations, and we can see how much money we could save if we've used these recommendations. I think this particular cluster might not quite have enough data, or here's a particular deployment we can see. These are really small clusters, so the savings isn't going to be much, but we've certainly had clients where we noticed in a number of their clusters that they were using way more requests than they needed, and we ended up saving them like over $10,000 a month, which, you know, in a year is pretty significant. And I think what happened with them is one developer, you know, they created a Kubernetes YAML manifest, and they had pretty high memory requests and limits. That way they could just get their app working, get it in the cluster, and they'll fix it later. The problem was every other developer copied that same template. And so every developer was using the same manifest that requested a lot of memory. And so in almost every single situation, they were paying for like 90% more resources than they needed. And so bringing that down to what they actually used made a huge effect. And you can see here too how this is going to be spread out over the number of pods. For this particular one, there's only 2 pods. So if you make these tweaks, it's only going to affect 2 workloads. But you might have deployments that have, you know, 30 pods or more. And so making that tweak on one will have that effect times 30. And so you can see how that would really start to add up. And so for people who are afraid or worried about cloud compute getting away from them, or cloud spend rather, this is a great way to get into the weeds for how we can actually do something about that. You know, we know that we're not using it efficiently. How do we actually fix that? This is where we can use data to figure that out. Anything you want to add there, John?
Nothing here. I think you got all the great points.
Awesome. So yep, that's a bit on reliability, a bit on cost as well. This was the cost. Talked about reliability, some in action items. Let's look at security. So we've got this vulnerabilities page, and a lot of this is coming in from Trivy. And so Trivy is scanning all of these things that are coming in. Looks like Cube Hunter is one of them, and it looks like we probably haven't updated it in a little bit. And so it's going to show us, you know, what are the vulnerabilities in all these different things. It looks like Jenkins has a number of vulnerabilities. And if we click on it, it's going to start to show us what those vulnerabilities actually are. So here we've got the image. Looks like there's 658 vulnerabilities in this image. If we click down, it's going to show us a little more information about each vulnerability. We could get more information. We can filter by critical, because maybe critical are the ones we care about. And for some of these, it's actually going to show a fixed version. So this particular vulnerability, it looks like there is no fixed version that addresses it. Maybe it'll come out in a week, you know, hopefully it'll come out soon. But for ones where it is fixed, it's going to show us a newer version that actually addresses that. And so it's a great way to know, like, am I just waiting? Like, could I be upgrading, or do I need to wait a little bit more to find a more recent version? Maybe some of these packages we don't actually use, and so we're not as interested in those, but maybe we know that there is a particular one that is used a lot more heavily, and then we can see what the actual vulnerabilities are in that package. And this is a great way to just kind of slice it a little more finely and see what information's there. Any thoughts on that, John?
No, it's a great point. I mean, the fix available is a real popular one for just having a path forward. And then one thing I believe was mentioned earlier, but you know, it's just an action items as well. Within Trivy, we provide some additional functionality on top of it, like base image recommendations. So there's a lot of different paths you can take to see like, should you be updating the base image, or should you be recompiling the existing image that you're using and have kind of a new standard image that you're rolling across your environment. So a lot of ways to kind of tackle this as well, but really just showing you that there is a path forward, and you don't have to really tackle issues that you don't have a path forward there.
Yeah, it's been a really helpful way to see all that information and figure out what we can do about it. Let's see. So another thing that John mentioned earlier is, we've talked a lot about how we have all of these open source plugins running in our cluster, but we also spoke about, shifting left and getting things into infrastructure as code and scanning them and everything. And so this is another place where we can plug in insights and a lot of these open source tools to get that information here as well. So as a developer or an engineer of some sort pushes code to the repo, we can use that CI process to trigger a bunch of these scans. So we can trigger things like Trivy to figure out what image vulnerabilities have come in. We can also use Polaris for best practices, like file system should be read-only. That's a great security configuration that if you don't need it, you should not have it, since that can cause some issues. And we can see that before it's even got into the cluster. So it's very similar to the actions item page, but this is all for things before they are even in the cluster. So if the engineer makes the commit or does a pull request and that triggers this workflow, now we can see what we actually need to address before we push this into our cluster. And so right away, we can also see that the geode repository in this particular deployment, there is a check where CPU requests should be set. We've decided as an organization that that's a best practice that we should have, and that's something that we would want to catch here so they can put that in place. We can see the recommendation. You can change your Kubernetes manifest to include these resource requests right here. And once we do that, that's going to, this check will pass. We won't see it anymore. And that's going to help us, match up with these best practices. So we can, auto scan repositories. We can connect it to GitHub, have it look at all our repositories, start to pick out what information is relevant. And yeah, great feature for shifting things left. Did you want to add something, John?
Oh, sure. Sorry. There's a little lapse in the audio there. Yeah, I actually had a customer recently. I don't know if anyone's going through their Kubernetes 1.22 upgrade. Good one with a lot of deprecations there, but we're actually able to show them in the repository view all of their resources that were affected and need to be all their API versions that need to be upgraded for 1.22. I think they had about 140 items that we discovered during that phase there. So if anyone's going through their 1.22 upgrade with all the ingress deprecations and all the fun ones that are out there, there's an answer.
And again, yeah, all of these are, like a lot of the tools here are open source. The platform is not, but if you look at Polaris or Trivy, these are things you can integrate into your CI pipeline to get this information. The challenge is doing it across all of your repos at scale and keeping track of all that. So yeah, feel free to play around with these. They're great tools. And yeah, happy to chat more. So what else? So John mentioned a bit about the policy and guardrails, and here's a great chance to look at that some. So OPA has a language called Rego that allows us to build rules. And these don't just affect Kubernetes. Like we can use OPA with things like Terraform. We can use them in a lot of different places where we want to put these rules. OPA kind of sits above these platforms, and you can use it in a lot of different situations. And we also have a library of different rules that you might want to use. Like one thing in particular is this DNS host name is too long. When you are issuing certificates for web endpoints in the cluster, you might use something like Cert Manager, which automatically goes out to like Let's Encrypt or something like that, and they're going to generate a certificate for you automatically. But what we've found with a lot of our clients is that there is a limit. There's this RFC 3280. It says that the common name or host name should not be greater than 63 characters. And so we found a number of clients where, pushing things to Kubernetes, Cert Manager would go to create a certificate for it. It would go to Let's Encrypt, but the host name would be longer than 63 characters, maybe 68. And so what would happen is it would fail, And then a few days later, the developer would wonder why there wasn't a certificate, why is this causing issues? And it turns out that that was the reason there. And so with a guardrail like this is something that we can catch before it even, before time even goes on. So if you put this policy in place, it's going to check right away to see, is that host name longer than 63 characters? If it is, let's create an action item right away. We could make it so that it's blocking. We could say you cannot deploy anything to the cluster if the host name is going to be longer than 63 characters. It's usually done by the ingress resources. That's where it's pulled from. And so there's some guardrails we can put up there. So as we onboard new engineers, everyone's going to shoot themselves in the foot at some point. We don't know everything. And so as we're learning, we, might cause an issue. This is a great way to limit that impact so that people can learn safely without having issues. This one might not be as important, or, it wouldn't bring down a cluster, for example, but there's a lot of things like maybe you require horizontal pod autoscalers. That's another great one where if you set that up, you can't deploy to the cluster unless you also have a horizontal pod autoscaler with it. So that's a great one for reliability as well. But yeah, great place to put guardrails in place. There's a library of different policies to look from. You can add your own, and there's a lot of flexibility there. Moving on to the automation rules. This is a little different than the policies. This is where we have things like create a Jira ticket or create a GitHub issue. These are things that come up automatically. So when we think about the action items as being triggers, the automation rules are where we define the behavior of what that trigger is going to do. So you might have something here like Slack alert, that as soon as an action item comes in and it's in the namespace testing and the CPU requests are not set, I want that to notify somebody on Slack at this particular channel. And so that's where this behavior is set up. There are some templates here as well. There's various different ones we can use. We're building out more all the time. And so, yeah, that's where we can automate a lot of that behavior. I know we're getting close to time. So do you want to add anything else before we stop for questions, John?
Nothing to add here. Just glad everyone's able to join today. So thanks for the time.
All right. And so, yeah, the last thing I think we'll mention is there is a Kubernetes white paper on the good, the bad, and the misconfigured. This goes into more detail on a lot of the different things that we talked about. And so I highly recommend you check that out. There's a link right here. I believe you'll also get a link through the platform or via email. So yeah, if you want to know more of the specifics about all these different pieces, that's where you can find more information. We'd also love to chat with you. We are pretty active in the open source community. We've got an open source Slack to talk about all these things. You can email us, get in touch. So yeah, with that, does anybody have any questions?
So I'm not seeing any questions at the moment. So while we give our audience just a few more seconds to send in any questions they may have, how about we give away those gift cards I mentioned at the top of the hour? So these are for 4 $25 Amazon gift cards. Our first winner is Herv C. Our second winner is Eric H. Our third winner is Nelius D. And our fourth and final winner is Muris A. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. But if you don't happen to find that email, please check your spam folder. I also take this opportunity to remind everyone that this session was recorded. So following this panel, you will receive an email with a link to access the recording on demand. You can also find the recording living on the Container Journal website. Just visit containerjournal.com/webinars and be sure to look in the on-demand section. All right, Rachel and John, I'm not seeing any more questions. So is there anything that you guys would like to mention or note before we close out?
Nothing on my end. Thank you so much. It's been a pleasure. And thank you, everyone, for joining us.
Yeah, this has been great. Thank you for the time.
Well, John and Rachel, thank you so much for joining us today. I would like to thank Fairwinds for sponsoring today's webinar. And I would also like to thank you, our audience. We really appreciate you spending time with us today. We ask for one extra moment of your time here to address a post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming TechStrong Learning webinar or workshop. Everyone, have a great rest of your day.